Hello students, welcome to my channel. Our today's topic of discussion is the equation of pair of straight lines. That means in this chapter we shall discuss about such an equation which will represent a pair of straight lines, means two straight lines together. For an example, let us consider an equation of straight line. Suppose I am taking the straight line is passing through origin as x minus 2y equal to 0, because if the straight line passes through the origin, then the constant part of the equation will be 0. And let's take another one which is also passing through origin, that is the constant part 0, as 2x plus 3y equal to 0. Now let us consider such an equation which will represent the both. How we will form it? Just multiply these two equations this way. X minus 2y into 2x plus 3y equal to 0. So this will represent the pair of equations, these two equations together, and hence as individually they are passing through 0, so obviously this equation will also be satisfied by the coordinate 0, 0, right? So here if we break it, we will get, if we multiply this 2, we will get 2x square plus 3xy minus 4xy minus 6y square equal to 0. So this will give us 2x square minus xy minus 6y square equal to 0. So this is the equation of the pair of lines, pair of straight lines passing through 0, 0, passing through origin means 0, 0. Okay, here both the lines are passing through the origin. That means if we generalize this structure, we will find ax square plus 2, suppose I am telling h, xy plus by square equal to 0. So this is the general structure or general equation of the pair of straight lines where both of them are passing through the origin. And make sure students, this is getting a homogeneous structure, right? If you divide both sides of this equation by y square, you will get a x by y square plus 2h into x by y plus b equal to 0, right? So this is a homogeneous equation of degree 2 because highest power of the variable here is 2. So it implies a homogeneous equation of degree 2 in x and y. Okay, so this is the standard formation of the pair of equations where both the equations are passing through the origin. Okay, so we have got that ax square plus 2hxy plus by square equals to 0. This homogeneous equation in x and y of degree 2 will represent a pair of lines, straight lines, passing through the origin. Now if we consider B is non-zero, let B not equals to 0. So obviously we can write it as ax square plus 2hxy plus by square equals to 0 equals to b into, here we can take b in common because b is non-zero we have considered, y square plus 2h by b into xy plus a by b into x squared. Okay. Now this portion will obviously, this structure, this formation will obviously represent the same, the pair of lines, straight lines passing through origin. So here we can write it as b into y minus m1x into y minus m2x. Because these are the standard forms, standard equations of the straight lines which pass through origin, where m1 and m2 are the slopes of those lines respectively, right? So here we get b into y square minus m2 into xy minus m1 into xy plus m1 into m2 into x squared. So this will give us b into y square minus m1 plus m2 into xy plus m1 into m2 x squared. Okay. Now if we compare these two structures, one is this one, another one is this one, what we will get? As the coefficient of xy, we will get here 2h by b, here minus within bracket m1 plus m2. And as the coefficient of x square, we will get a by b here and m1 into m2 here. And in both the cases, coefficient of y square is 1, right? So here we get, so from this we can write m1 plus m2 minus of m1 plus m2 equals to 2h by b, that is m1 plus m2 equals to minus 2h by b, and m1 into m2 equals to a by b. These are very important relations between the slopes of the straight lines which are represented by the given homogeneous equation. Now we shall learn how to find out the angles between the pair of straight lines and here we are considering that, right now we are considering that the lines are passing through the origin. Okay. Now we know that the standard form ax square plus 2hxy plus by square equals to 0 will represent the pair of lines which pass through the origin. Okay, this is known to all of us right now. Now make sure, students, that obviously these two lines which are together represented by this homogeneous equation will make an angle between each other. Okay. Now let us consider that particular angle as theta. Let the angle is theta and y minus m1x equals to 0, y minus m2x equals to 0 are the straight lines represented by, suppose this is equation 1, this homogeneous equation, are the straight lines represented by 1, right? So here we know the way of determining the angle between these two lines is tan theta equals to m1 minus m2, because we don't know which one is greater. So that's why this difference sign is written here, by 1 plus m1 m2. Okay. Now look students, this one can be written as m1 difference m2 square, and hence it is kept within the square root. So obviously the thing will remain the same, by 1 plus m1 m2. Why we are doing this? Because we now want to represent this entire thing in terms of a, b, h, right? So now this can be written as, within root sign, m1 plus m2 square minus 4 m1 m2 by 1 plus m1 m2. Now from the previous part we have known that this m1 plus m2 is equals to minus 2h by b, and m1 into m2 equals to a by b, right? So let's replace this. Let's write it as root over minus 2h by b square minus 4 into a by b by 1 plus a by b. Now after simplification we will get root over 4h square minus 4ab by b, because this b square will come out of this root sign, so it will be b, by a plus b by b. So after the simplification we can write 2, because this 4 will come out of the square root sign, it will become 2, root over h square minus ab by a plus b. So this is the way of, or this is the formula of determining the angle between the pair of lines which are represented by this homogeneous equation. So here we have got that tan theta equals to 2 into root over h square minus ab by a plus b. So if we think about this structure, we will find that when theta is 0, okay, theta is 0 means when theta is 0 degree, right? Then what will happen? Obviously this 2 into root over h square minus ab by a plus b will be 0. Theta 0 means what? Because tan 0 degree is 0. Now theta 0 degree means what? It means that the lines are coincident, right? The lines are coincident here. So now if we simplify this, we will get h square minus ab equals to 0. So h square minus ab equals to 0 will give you the condition of the lines to be coincident. The condition of lines, of straight lines to be coincident. Okay. Now when, this is case 1, suppose, when theta is 90 degree, then what will happen? Tan 90 degree means what? Undefined, right? So tan 90 degree is not defined. So we can write that this one is undefined. So we can write a plus b equals to 0 in that case, because if this one is undefined, then its inverse is 0 as per rule. So this is the condition. Now tan 90, that is theta 90 degree means what? The lines are perpendicular to each other. Okay. So this is the condition of the straight lines to be perpendicular. So look students, here we have also got the ways of understanding that whether the pair of lines which are passing through the origin and represented by that homogeneous equation are coincident or whether they are perpendicular to each other. Here one thing must mention that the positive value of tan theta, which will determine by this formula, will give you the measurement of the acute angle between the pair of straight lines, and the negative value will give you the measurement of the obtuse angle between them. Okay? Okay. Now we shall find out the equation of bisectors of the angles between the straight lines. Okay, represented by ax square plus 2hxy, that's standard form, plus by square equals to 0, right? Because you know, rectangular Cartesian coordinate system, this is 0, 0 origin. Now the lines are passing through this origin. From the beginning we are considering this. Suppose this one is y minus m1x equals to 0 and this one is y minus m2x equals to 0. So obviously we can consider the bisectors of the angles between these two pair of lines. Okay students, and make sure that these bisectors will also be the pair of lines. And what is meant by bisectors? Bisectors is nothing but the locus of the point. I repeat, the locus of the point which remains equidistant from both the lines, right? Now let's learn how to find out this locus. Now let us consider a point P having coordinate x1, y1 lying on either of these two bisectors. So by definition, this P will be equidistant from both the lines. Okay. So here by that logic, we can write y1 minus m1 x1 by root over 1 plus m1 square equals to plus minus y1 minus m2 x1 by root over 1 plus m2 square. Okay. So now after squaring both sides and then after cross multiplication, we will get 1 plus m2 square into y1 minus m1 x1 whole square equals to 1 plus m1 square into y1 minus m2 x1 whole square. Now we have to do a very simple calculation. That is, first of all we have to expand this one by using formula 1 plus m2 square into y1 square minus 2 y1 m1 x1 plus m1 square x1 square equals to 1 plus m1 square into y1 square minus 2 y1 m2 x1 plus m2 square x1 square. Okay. Now we have to just multiply these expressions on both sides of the equal sign. And then after multiplication and then after grouping all the terms as the coefficients in terms of the coefficients of x1 square, y1 square and x1 y1, we will get ultimately, you can do this calculation yourself, then we will get after the calculation and after all the groupings x1 square into m1 square minus m2 square minus y1 square into m1 square minus m2 square equals to 2x1 y1 into m1 minus m2 into 1 minus m1 m2. Okay? So, it is clear to us that the coefficients is in terms of m1, m2 of x1 square and y1 square are the same. So, here we can write x1 square minus y1 square, that is taking m1 square minus m2 square in common, and then after cross multiplication 2x1 y1 into m1 minus m2, very simple calculation, 1 minus m1 m2 by m1 square minus m2 square. Okay. So now this m1 square minus m2 square can be broken into formula m1 plus m2 into m1 minus m2, and this two part will be cancelled. So this will ultimately give us 2x1 y1 into 1 minus m1 m2 by m1 plus m2. Now we have already known that m1 plus m2 is equals to minus of twice h by b, and m1 into m2 equals to a by b. So let's replace them in terms of a, b, h. So x1 square minus y1 square is equals to 2 into x1 y1 into 1 minus a by b by minus of twice h by b. These twos are cancelled, and hence we will get x1 y1 into b minus a, and in denominator portion we will get 1b, which will be cancelled with it, by minus h. So this can be also written as a minus b into x1 y1 by h. Okay. So now this can also be represented as x1 square minus y1 square by a minus b equals to x1 y1 by h. So look students, this is the locus of the point P x1 y1, right? Which will give you the equation of the bisector. So equation of the bisector pair of bisectors is x square minus y square by a minus b equals to xy by h. This is the equation of the pair of bisectors of the angles between the pair of straight lines. Okay. So now please go through the concept of pair of straight lines. In my next video, I'll discuss about different applications based on this portion. Till then, take care.